Hi students, uh, regarding decays we concluded that is the radioactivity process we seen, right? That is during the disintegration or radioactive process there, the unstable nucleus is coming to stable by emitting alpha, beta and gamma radiations. That process is radioactivity, and that we covered in the last two videos, right? Now here the rate of decay or disintegration, that means how that reaction can be goes with a time period, that means in the duration time is lapse or goes on increases, how that reaction rate of reaction or the number of nucleons or disintegration, how it will takes place. So that is calculated or observed by knowing a simple calculation or derivation, an equation called as a radioactive decay law. So here radioactive decay law, that means here how many number of nucleons are present in that nucleus after some instant of time, or at any instant of time you can be find out in that how many nuclei exist or how many are decayed, lost, or they can be disintegrated, they are not existing in that nucleus after some time because it has a radioactivity process. So that is we can be having here. So depends upon the rate of decay, that is that rate of decay is depends upon the rate of disintegration is depends upon the how many nucleons are present in that nucleus. The more number of nucleons are there the rate of disintegration is more. When the rate of disintegration is goes on decreases as the number of nucleons are disintegrated, right? So number of nucleons are reducing, automatically that rate of disintegration also decreases, right? So that is we can be observed in this further class or in this class, in this video, that is called as the disintegration law or radioactive decay law. So what is the statement of the radioactive decay law? And it is a very very important for your calculations or board or everything, it is important. What is the radioactive decay law? So it is a statement, the rate of disintegration, the rate of disintegration for any radioactive nuclei, for any radioactive nuclei, the rate of disintegration is directly proportional to number of nucleons present in that nucleus at that instant of time. So at which instant of time we want to find out the rate of disintegration, that is the rate of decay. At that instant of time, how many nucleons are present in that, based on that the rate of the disintegration is depends. So that is nothing but, that is we have the decay law, that is a radioactive decay law. So statement of this one is the rate of disintegration is directly proportional to number of nucleons present in that radioactive sample at that instant of time when we are calculating the rate of disintegration or the activity. That is nothing but rate of disintegration only, it is called activity. So the activity of the radioactive sample you want to calculate at any instant of time, that will be gives you how many number of nucleons are present in that radioactive sample. So that is called as a radioactive decay law, right? So here the radioactive decay law states, or it can be having the definition is the rate of disintegration, the rate of disintegration, the rate of disintegration of a radioactive sample, of a radioactive sample or nuclei, whatever, radioactive sample is directly proportional to directly proportional to number of nucleons present at that instant of time, present at that instant of time in that sample, right, is called radioactive decay law, is called radioactive decay law, right? So this is the statement for this radioactive decay law. That means the rate of disintegration or how many number of nucleons are decaying per second, it depends on what factor, how many nucleons are existing in that sample at that instant of time. So that is called as the radioactive decay law, right? So After, let it be you are taking any radioactive sample, in that some number of nucleons are there. So after some instant of time t, at that instant how many nucleons are present, how we can be calculated? So there is simple calculation is there. So derivation is there, that is the number of nucleons at any instant of time we can be calculated that by an equation. That equation we can be derived now, and that equation is in the form of exponential form. That means the number of nucleons existing in the any radioactive sample is inversely decreasing exponentially, or exponentially decreases. The number of nucleons in any radioactive sample will be decreases exponentially with respect to time period. So that equation we can be derived. So here we can be observed for derivation for number of nucleons at any instant of time, right? So for that, what is the equation? So for that, let I am considering a radioactive sample. Let a radioactive sample has initially how many are there? The number of nucleons in that we have, it is n naught number of sample are there. So right, let n naught be the number of nucleons initially at time period t is equal to 0. When the time period t is equal to 0, in that how many nucleons are there? N naught number of nucleons are there. After some time interval t seconds, in that only n number of nucleons are there. So after, let n be number of nucleons at t seconds. So when the time period t is equal to 0 second, initially we have this many number of nucleons are there. After some time period t seconds, we have the number of nucleons are only n, right? So what is this n in terms of n naught and time period? So that equation is called as a radioactive decay law. We can be get at any instant of time how many nucleons are present in that sample, that we can be determined. So use this simple radioactive decay law. So we have here rate of disintegration. See this, rate of disintegration means, rate means how many nucleons are decayed per second. That is called rate of disintegration, which is also called as activity, right? So now I can write here by radioactive decay law, by radioactive decay law, by radioactive decay law, we have this is rate of disintegration dN by dt is proportional to what do you have? Number of nucleons at that instant of time. So at this time period t, how many nucleons are there? N number of nucleons are there, right? Don't take n naught, not n naught. It is at this instant of time you want to find out number of nucleons after some time period at any instant of time t. How many nucleons are there? So that is n. So here the rate of disintegration is directly proportional to number of nucleons at that instant of time, right? So from this I can write dN by dt. Here it is a proportional is there, right? So I can put this one, it is equal to, by taking a proportionality constant lambda into n. And I already said with respect to time period, the number of nucleons will be goes on decreasing in that sample. So the decreasing represent here, it is a minus sign I am taking. This minus sign in this equation will be taken or considered because with respect to time period, or this rate of disintegration will be goes on decreasing as the number of nucleons are decreases in the sample. Because of that we are taking here negative sign. Okay. Now from this we want to write our equation for which one it is? N. For that just you write the variable separable. That is number of nucleons you write one side. Here time period is another side. Here only two variables are there. Number of nucleons of time period, what is the relation? So that we can get. Here this proportionality constant lambda, which is known as a disintegration constant. Where this lambda is called disintegration constant, or sometimes it is also called as a decay constant. Disintegration constant, or it is also named as decay constant. Decay constant, right? So now from this equation I can write here it is dN by n is equal to minus lambda t. Just I am taking this n to this side, t to d to RHS. Now here this is a number of nucleons, here we have time period is RHS. So both are separate. One side we have taken number of nucleons, another side we have taken the time period. Now make the integration on both sides. Integration on both sides. You can take directly limits or without limits also you can take, but I am taking the integration on both sides. Integration on both sides. Integration on both sides. Then what you can write, this one is integration of dn by n is equal to integration of lambda is constant, and here it is a dt is there. I am not written dt. I can write here this is a lambda dt. So lambda integration of dt. Now this is nothing but here you have 1 by n, integration of 1 by n dn. It is 1 by n dn, and minus lambda integration of dt is a t, plus some integration constant c, and integration of this one is, it is a log base e, exponential base. So this can be written as ln. Log base e is represented as ln. Logarithm of exponential base you can write, logarithm of base of 10 also you can write. So I am writing here this exponential base, I am representing ln. Ln of which one it is, n, is equal to minus lambda t plus c. So this is the equation we have, let it be 1. Now here this integration constant we can be calculated by taking the limits. That limits are nothing but if time period is equal to 0, the number of nucleons are nothing but how many, n naught. So in place of time period you put 0, and in place of n you put n naught, then you can get this constant value. So now by taking these limits and substituting in the equation 1, then we can get this one is ln n naught is equal to minus lambda t. T is here we have 0 plus c. Then what you can get, c is equal to it is ln of n naught. So make it second equation. So in place of this constant c you put this value ln of n2, that is logarithm exponential base n naught we have, that is equal to the c. So in place of this constant, integration constant, you substitute this value by combining 1 and 2. What you can write here, from 1 and 2 we can write here ln n is equal to minus lambda t plus c. C is how much, ln of n naught, right? So here logarithm, here logarithm, that is exponential base. You bring this one to this side, that I can put here, it is ln of n minus ln of n naught, which is equal to minus lambda t, right? Now here log a minus log b, log a by b, same apply here. You can write it, this one is ln of n by n naught. This is ln means logarithm exponential base is equal to minus lambda t. We want to require to write the equation for n, so but it is there within the log. So this logarithm to be eliminated by taking the exponential on both sides. So now here what you are doing, you are taking exponential on both sides. So then we can get this one is exponential of log of exponential, means you will get only within this. That means by taking the exponential here, what you can get here, e power of ln of n by n naught is equal to e power of minus lambda t. That is taking exponential on both sides. So from this what you can be observed here, this logarithm will be gone, this 2 will be cancelled. What is the remaining value? It will be become as n by n naught is equal to e power minus lambda t. So we can write here what is the n naught, n value is given by n naught into e power minus lambda t. See here, n t is initial number of nucleons, lambda is a decay constant. The decay constant is a constant for given sample. It will not be altered with respect to time period. For any radioactive sample, the lambda is constant. So these two are constant here. So at any instant of time t, the number of nucleons we can be determined, right? So that means when the time period increases, this value will be increasing. Exponential value will be increases in denominator. Means the number of nucleons will be goes on decreasing exponentially with respect to time period, right? So that is you can be observed by using this equation, right? Now you can be put, or we can be having here this number of nucleons with respect to time period. When you draw the graph will be exponentially decreasing curve you can be get, right? So that is what you can be observed to be having. Here I can write. This is the number of nucleons at any instant of time is given. The equation is this one. That means the number of nucleons in any radioactive sample will be decreasing exponentially. That will be shows this equation itself, right? So this is the required equation. That is third equation. Let it be. So this is a important one. The number of nucleons at any instant of time is given by n is equal to n naught e power minus lambda t. What is the lambda? It is decay constant or disintegration constant. Decay constant or disintegration constant. And what about the n naught? Initial number of nucleons existing in the radioactive sample. After some time interval or at an instant of time t, how many nucleons are present in that? That is given by this n value. Right? N is equal to n naught e power minus lambda t is the number of nucleons at any instant of time we can be determined. So if you draw the graph between this number of nucleons with respect to time period, you will get an exponential curve with decreasing with respect to time period that you can be get. So that is here n versus t graph. Number of nucleons with respect to time period, how it will be changes. So that you can be get here. The graph can be observed here. This is the time period we taken along the x-axis. And along the y-axis, the number of nucleons. When the time period t is equal to 0, the number of nucleons you can be having the maximum, that is n naught. So when the time period goes on increases, this number of nucleons will be goes on decreases exponentially. Okay, like this you can be get. This is exponential decreases. Exponential decreases. Exponential decreasing. That is what you can be get this graph. Right? And if you observe this graph itself, that is where you can be see this equation. This one if you observe, ln n is equal to lambda minus lambda t into ln naught, n naught. We have this equation, right? So this will be, I am writing here ln n, I am taking on x-axis, y-axis, and time period I am taking on x-axis. That means this equation will be looks like a straight line equation having the slope is lambda with a decreasing. Negative slope you can be having. So this is a constant. ln of n naught is constant. So constant here, this is an intercept you can be having, right? And this one is when you draw the graph between ln of n with respect to time period, you will get a straight line with a negative slope of minus lambda you can be get. So I am drawing here graph between which one and which one? It is log n versus a time period. When you draw the graph, you will get a straight line. So how you can get that graph? Here you can be get this graph as here. This is I am taking log n here along the y-axis, and here the time period I am taking along x-axis, and you are getting a straight line decreasing. So the slope of this one is a minus lambda you can be get. And here when the time period t is equal to 0, suppose you are putting here t is equal to 0, this value will become 0. That means ln n is nothing but what? ln n naught only. So this value is ln n naught. And when the time period increases, you are getting the decreasing order, like this it will be. At infinity time, or depends upon the value for the respective radioactive sample, it will be intersect this x-axis. I am not intersecting, just I am drawing here. This will be having the which one? Negative slope. How much it is? Negative slope is equal to this minus lambda, or it is lambda. Negative slope is equal to minus lambda. That you can be get. So this is the observation what you can be seen for this radioactive decay law. So basically you can be remember this equation. It is very important, or this one. These two are very important. How we got that? Very simple and easily we can be determined, or we derived this one by using this radioactive decay law. Right? By using this radioactive decay law, we have the information, or we can be derived the number of nucleons in the radioactive samples are decreasing exponentially with respect to time period. So that we can be derived. That equation is nothing but this third equation, right? And we draw the graph between the number of nucleons with respect to time period and logarithm of n with respect to time period. It is a straight line with a negative slope of minus lambda you will get, right? And here I written this or drawn this graph of number of nucleons, how they are changing, decreasing with respect to time period. Suppose if you are calculating number of nucleons are decayed with respect to time period, if you want to draw the graph, how many number of nucleons are decayed? That number of nucleons are decayed with respect to time period. When your time period is increasing, number of nucleons also decayed also increasing. right? But how it is increases? Exponentially increases. So that you can be observed to be, the graph will be, with respect to this one, it will becomes like this. That graph, okay, we can be see, or we can be observed in the next video, right? But as of now, you just observe how we did or what we did here, right? Followed, it is very, very important. So what is a radioactive decay law? What is a statement? And by using that radioactive decay law, what we can be derived? That is, the number of nucleons in the radioactive sample decreases exponentially. That we can be shown or proved by making this derivation till this equation n is equal to n naught e power minus lambda t. Correct? So this, what is the lambda here? It is a proportionality constant named as disintegration constant or decay constant. So it has a unit is unit or SI unit. It will be per second. Per second is the SI unit for decay constant or disintegration constant. So that we can be see or we can be observed in the next video, right? Okay, see you.